Hi everyone, our lesson today is permutation with replacement, repetition or return. We have a problem 1. An urn contains 3 balls marked A, B and C. So how many possible outcomes can we have if we withdraw the balls as follows? Withdrawing the balls in 3 consecutive turns. After each withdrawal, we return the ball to the urn and we write the name of the withdrawn balls in order. So let's see how to do that. Here we have a container with 3 objects. We withdraw ball A and we write it down. After that, we return the ball to the container and we mix the balls again. Why we mix the balls? Because we want to guarantee that the event of the withdrawal is random. So let's move to the second withdrawal. We withdraw ball C and we write it here as ball C. We return it to the urn and we mix the container again. Now the third withdrawal, we are withdrawing ball A and writing it down, and we are returning it to the container or the urn and we are mixing the balls again. So here we have first withdrawal and second withdrawal and third withdrawals. Finally, we obtain the sequence ACA. So what does this sequence represent? The sequence ACA, the first symbol, represents the first event, which is withdrawing ball A, and C represents the second event, which is withdrawing ball C, and A represents the third event, withdrawing ball A. Now we have to define the number of event occurrences. We have 3 events: the first event and the second event and the third event. So we have 3 events, and each event represents a withdrawal of a ball, and we can call that also length of event sequence, length of generated sequence, or number of symbols in the sequence. They all refer to the same thing, which is number of event occurrences, which is 3. We are withdrawing 3 times. So now let's compute the number of all possibilities using the tree diagram under the previous 3 conditions, which are the first condition and the second and the third, which we mentioned earlier. So for the first withdrawal or first event, we may withdraw object A or B or C. And in the second event, let's assume we have withdrawn object A. So we may withdraw object A again, or B or C. Why we may withdraw object A? Because we have returned A to the container again. So this is the second event. Now the third event, if we withdraw A, we are again faced with the 3 possibilities of withdrawing A or B and C from the container. So now let's compute how many possibilities we have here. We are going to divide it into 3 subtrees, the first one and the second one and the third one. But we have to keep in mind that the sequence ABB is different than BBA, even though we have 2 B's in it here, and we have 2 B's here, and we have 1A and 1A, and the reason is we focus on the order of events. So here we are withdrawing object A first and B second and B third, and here we are withdrawing B first and B second and A third. So these are 2 different events, and they are going, each one is going to be counted by itself. So the number of possibilities for the first subtree is 3 by 3. And the reason we have 3 branches here repeating 3 times. And the same thing applies for the other 2 subtrees here. Now we add them together and we get 3 times 3 3 times, which is 3 to the power of 3, or n to the power of n. So what is n and what is the exponent n? To understand that, we are going to use this formula here, PRNN. So what does that mean? P means permutation, which implies order. If we look this word in the dictionary, we will find that it implies order. And R means with replacement or replacement. Or we can say also with repetition or with return. So we can say here permutation with replacement, permutation with repetition, permutation with return, all means the same thing. Now this n here means the number of objects we have. And this n here on the right side of P means ways of event occurrences or sequence lengths. So n to the power of n is equal to the permutation with replacement of n different objects happening n times or taken n at a time. And here it's written underneath. Now there is different notation you may find in other books, and this notation is P. In between parentheses we have n, comma, and n. I have added this R here because students of probabilities, they suffer a lot from replacement and no replacement. So let's write this formula in very clear way, indicating that permutation is with replacement. And if we don't write R on top, it means this permutation is not with replacement. So now we have to write down the meaning of every symbol. N is number of objects in the set, and this n, the blue one, is number of ways of event occurrences or length of event sequence or length of generated sequence or number of symbols in the sequence. They all mean the same thing. So this formula here is very important to know the conditions according to which we can apply it. And these conditions are: the first one, order of object is important. And the second one, withdrawing is with replacement. And the third one, number of object is the number of ways of event occurrences. If one of these conditions are not met, we cannot apply this formula. So going back to the older problem, we have the 3 conditions according to which this problem is taking place, and we have seen all possible outcomes highlighted here, and we computed the number of all possible sequences or all possible event occurrences in order and with replacement. But under the condition that number of events is equal to the number of objects in the set, so R is equal to N. Now we are going to solve this issue in general. First of all, if we realize that there is an order in the problem, we have to define the event also in order. So first event withdrawing the first object, and second event withdrawing the second object, and third event withdrawing the third object. And after that, we can write down this table which shows the number of events and the events in order. So first event, second event, third event. And number of event occurrences for the first event is 3 ways, the second event 3 ways, and the third event 3 ways. And after that, we get the number of all event occurrences in order and with replacement, which means all possible outcome of the event withdrawal. And they are 3 times 3 times 3, which is 3 to the power 3, which is 27 possible outcome. Now we can use this formula by substituting n equal to 3, and we're getting 27. Now we can do it in more abstract way. We imagine filling a sequence of 3 cells from a set A, B, and C. The first cell can be filled in 3 ways, and since the object can be replaced, the second and the third cell can be filled in 3 different ways too. So here we have the first cell, the second cell, and the third cell, and number of ways of filling the cell, 3 ways, second cell, 3 ways, third cell, 3 ways, and number of permutation, 3 times 3 times 3. And as a reminder, before we apply this formula, we have to make sure that these 3 conditions are met before we apply it. Otherwise, we are going to have a mistake. And very important things for all probability students to remember that they have always to imagine the events very clearly before they decide what to do and which formula they should apply. We are going to see that later. Thank you.